Alright, this is lesson 3.1 and this is on integer exponents. So let's go ahead and make a couple tables. We're going to start midway down your paper and I want us to look at 2 to the first power. And let's recall that when we have integers, this is the base, the 2 is the base, and the 1 is the exponent. So 2 to the first power is just 2. And 2 to the second power is 2 times another 2, so that's going to give us 4. And 2 to the third power is 2 times 2 times 2, so that's 8, not 6, because it's not 2 times 3, it's 2, and then 3 copies of it. And then finally 2 to the fourth is going to give us 2 times 2 times 2 times 2, which is 16. If you notice the pattern, starting with 2 to the first, to get to 2 to the second, we just multiply by 2. And from 2 to the second to 2 to the third, 4 times 2 is 8. 8 times 2 is 16. So we can continue that pattern back up the list, and we can look at 2 to the 0 power, and that technically should be, well, let's see, 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1. And my pattern's working 4, 3, 2, 1, 0. So 2 to the 0 power is 1. Let's keep going back. The next one would be 2 to the negative first power. It doesn't mean that we have, it doesn't mean that we have a negative answer. We follow our pattern. So 2 divided by 2 is 1. 1 divided by 2 is a half. Well, let's try 2 to the negative 2 power. A half divided by 2 is a fourth. And then if we want to go 2 to the negative third power, a fourth divided by 2 is an eighth. I think you can probably see something special is happening here, 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 etc. Let's table that for just a minute and then let's come over here. We're going to make another list. Let's do 10 to the first power. I chose 2's and 10's because they're pretty easy to do in our head. So 10 to the first power is just 10. 10 to the second power is 10 times 10, so that's 100. 10 to the third power is 10 times 10 times 10. And this is kind of nice. When you have 10s as your base, you just keep adding the zeros depending on what your exponent is. So 10 to the fourth power would be 10,000. So if you look at our pattern here, 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000, and we can work back up. 10,000 divided by 10 is 1,000, divided by 10 is 100, divided by 10 is 10. So 10 to the 0 would be 10 divided by 10, which is 1. And then 10 to the negative 1 is 1 divided by 10, which is a tenth. And 10 to the negative 2 is 1/10 divided by 10, which is 1/100th, or we can write it as a decimal. So 10 to the negative 3 is going to be 1/1000th, and we write it like this. And again, I'm betting that you can see there is a relationship between these pairings. So if I had 2 to the negative 4, for example, really that's going to be 1/16. And to get that, it's 1 over 2 to the positive 4. So it's 1/16 because 2 to the 4th was 16. If I wanted 10 to the negative 4th, for example, that's going to be 1/10,000ths, which is 1/10 to the positive 4, which is 1/10,000th. Or as a decimal, we could write it like this. So here, the next slide is giving you the official rule. Any non-zero number, so we're taking a non-zero number raised to a negative power. So non-zero means it could be negative base, but it can't be zero here. If we raise it to a negative power, it equals 1 divided by that number raised to the positive power. So 5 to the negative third is really 1/5 to the positive third. 5 to the third is 5 times 5 times 5, so it's 1/125. Here is the algebraic form. So I want you to write, well, I want you to write all of this down, but make sure you have this. So b to the negative n is really 1/b to the positive n. Notice that base did not change. I did not make this b a negative b. I did not make this 5 a negative 5. It's the same number. I only changed the exponent. And again, here b cannot equal 0 because you cannot divide by 0. All right, let's do a couple examples. If I have 10 to the negative second, and I really kind of already did a lot of these, that's going to be 1/10 squared. They're asking us to write this in decimal form, so you can grab your calculator if you want. Oops. And I would go 1 divided by 100. And we already know that that's going to be 0.01 or 1/100th. So this will be 1/10 to the positive 7. So I'm going to grab my calculator and I'm going to change it to scientific. Let's get it out here. So I'm going to go 1 divided by, and I'm put it in parentheses, 10 parenthesis to the power of, let me find that on here, right here, 7 equals. So really what that is 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6 zeros in the 1. So we have 1 less 0 than we have. Okay, as I was saying here, for 10 to the 7th, you only need the 6 zeros because it's to the 7th power, so you just take one of the zeros off because the 1 takes its place. 10 to the negative 6 is 1/10 to the positive 6, so we're going to need 5 zeros. And 10 to the negative 10th is 1/10 to the positive 10th. And how many zeros do we need? 9. Whoop. Close enough to a 0. Okay, now in some cases your base is not going to be a 10, it's going to be another integer, or in some cases a rational number, but we'll get to those another time. So let's go ahead and simplify this. 2 to the negative 6 becomes 1/2 to the positive 6. And then if they want us to simplify that, that means they really want us to take 2 to the 6th power. They're not asking us to write this as a decimal. So 2 to the 6th means that you have 2 times 2 times 2 times 2 times 2 times 2, which happens to be 64. Negative 3 to the negative 4, I go 1/, I keep my base as a negative 3, and I change my exponent to the positive 4. So we know a negative times a negative is a positive, times another negative is a negative, but times another negative is a positive. So this answer is going to be positive even though we started out with a negative base. Negative 3 to the 4th power is 81. 3 to the negative 3 is 1 over 3 to the positive third power, or 1 over 3 cubed. 3 times 3 times 3 is 27. And finally on this one, negative 2 to the negative 5 power is 1 over negative 2. Again, keep that base to the positive 5. A negative to an odd power is going to be odd. That I suggest you write down. A negative to an odd power is odd. A negative to an even power is going to be even. So this is going to be negative 1 over 32. Okay, so in some of your problems, they're just going to have you go ahead and simplify these exponents with the negative exponents. And in some cases, they're going to have you do order of operations, like the following. Well, I guess first, I'm getting a little ahead of myself. Don't forget that anything to the 0 power, we looked at this back here, 2 to the 0 is 1, 10 to the 0 is 1. Any 0 power, or the 0 power of any number except 0 equals 1. So you cannot take 0 to the 0 power. We just say, no, don't do it, don't do it. So 100 to the 0 is 1, negative 7 to the 0 is 1, and this is the algebra statement. A to the 0 power is 1, again, as long as A does not equal 0. So here we're going to do some order of operations problems. Excuse me. We remember, please excuse my dear Aunt Sally, we're going to do parentheses first. So we have 4 plus 3 times the quantity 4 minus, well, 9 to the 0 is 1, plus 5 to the negative 3. I'm still not done in my parentheses, so I'll take another step for that. 4 plus 3 times 4 minus 1 is 3, plus 5 to the negative third power. That takes care of the parentheses. Now I have exponents. Well, I do have an exponent, so I'll take this and make it 4 plus 3 times 3 plus 1 over 5 to the positive third power. I'm still not done simplifying this because there's an exponent. So 4 plus 3 times 3 plus 1 over 5 times 5 times 5 is 125. I'll take this up here now. So I'm going to do my multiplication. So I have 4 plus 9. 3 times 3 is 9, plus 1 over 125. 4 plus 9 is 13. And I'm just going to call this 13 plus 1 over 125, which is 13 and 1 125th. And I'm going to leave it right like that. So 13 and 1 125th. Let's try number 10. So I know you want to look at this and say, ooh, parentheses, parentheses, but we don't look at that as parentheses. This is just multiplication. It's holding my base right here. So I do have an exponent. So I have 7 minus 8 times 1 over 2 to the third. If you want to leave that in parentheses, you can, but I prefer to use the dot. Plus 13. So now I have to still deal with my exponent. So 7 minus 8 times 1 over 2 to the third power is 8. Plus 13. So now I have my multiplication. So 7 minus, well, 8 times 1 is 8 over 8 gives me 1. 8 times 1 is 8, but over 8 is 1. And then plus 13. Now I just add and subtract from left to right. So 7 minus 1 is 6 plus 13 is 19. Okay, I've got a couple sets of parentheses in here. So 2 plus 2 is 4 to the negative 2 power. Plus 1 plus 1 is 2 to the negative 4th power. So this becomes My little Mimeo board gives me trouble when I'm recording. It goes a little slower. So 1 over 4 to the second plus 1 over 2 to the fourth. That gives me, I'll put it up here, 4 to the second is 16, 4 times 4. 2 to the fourth, that's 16 also. How about that? See if you can make the connection on why those would be the same number. And then remember, when you have a common denominator, you're good to add the numerators. So this is 2/16, and common multiple here is 2, so the least common denominator, or the least common multiple is 2, or the greatest common factor I should say is 2, sorry. So this becomes 1/8. And let's try one more. So I have 2 minus 2 to the negative third power, so that's going to be 2 minus 1 over 2 to the positive third power, or 2 minus 1 over 8. So if I just think about this, if I have 2 whole and I'm subtracting an 1/8, I'm going to have 1 with 7 of the 8 parts left over. So 1 and 7/8. Okay, that's it for your notes. Come in tomorrow with your questions. Make sure that you have all of these examples done. And if you actually have questions tonight, you can email them to me, and throughout the night I will periodically check my email, so you also check yours to see if I've responded.